Good evening, everyone. Uh, yeah, I originally planned on doing this video at the school, um, but I went and watched the play, which, by the way, awesome job everyone that participated in it. Uh, when I went there, I left my keys in my room, so I guess I'm going to be doing this video at home. Anyway, this is the start of chapter 4. There are three concepts in this section. The first one being classifying triangles. This word classify lets you know how do we call it a certain name. Now they're all triangles, but each of them have a different way of being called. For instance, we can classify triangles by their sides, whether they are congruent or not. The three main ones are scalene, isosceles, and equilateral. Well, scalene have no congruent sides, so if I look at this triangle right here, it's scalene because all the sides are not congruent. This one here is isosceles, at least two sides are congruent. The last one is equilateral, all three sides are congruent. So when I classify a triangle, I'm just kind of saying a more specific thing about the triangle. Yeah, I know before we might have said classify. We might have been talking about convex or concave. In this case, all triangles are convex, so you don't need to say a convex scalene triangle. Triangles are convex. The other way we can classify triangles is by their angle measures. Either it's going to be acute, right, obtuse, or the last case, equal angular triangle. Of the four types of angles, three of them are represented in the type of triangle. The only one not shown is the straight angle, which in concept 2 I'll explain why the straight angle is not possible. However, an acute triangle is where all angles of the triangle are acute. For instance, this angle here looks to be about 70, this angle here looks to be about 50, and this angle here looks to be about 60. All of them are acute. This one here, one of the angles, and only one of the angles will be a right angle. This triangle is a right triangle because this angle right here ends up being a right angle. I didn't mark it. I should have. And the last unique one is obtuse triangle. One of the angles and only one is obtuse. The other two will be acute. In both the right triangle and obtuse triangle, this is true. And the last one is equal angular triangle. All the angles end up being congruent. Equal angular is also an acute triangle because all those angles have to be 60 degrees. However, we're just going to call it equal angular. I can call something, for instance, this one here, a scalene acute triangle. I can also call it scalene right triangle or scalene obtuse triangle. I can classify both as the number of sides and by the angle. So when I say classify triangle, there's two ways to classify it. Name both. In example 1 here, a triangle has been given the vertices. Graph the triangle and classify it by its sides, then determine if it is a right triangle. Alright, for this example, what I'll be doing is I'll be plotting it on my makeshift grid here. The first thing on this type of problem, because it's asking me to graph the triangle, I have to plot all three of those points. Remember, the first number here, for instance, an A, that's the x-coordinate. So A is 2, so I count 1, 2 over. And then 3 is the y-coordinate, so I count 3 up. And I make a dot right at 2, 3, and I'm going to label that point A. As such. Then I do the same thing for B. Count 6 over, and 3 up. And I'm going to label it B. The last thing I need to do is 2, 7, so 2 over, 7 up. And I'm going to label that C. Now that I have my 3 points, I just connect the dots. Normally I'd be using a ruler for this. And there we go. We have my triangle. Now, if I'm just going to be classifying it by its sides, I need to know if any of these sides are congruent. So what I'm going to do is find the length of each of them using the distance formula. If you forgot what the distance formula is, here it is right here. So for each point, what I'm going to have to do is plug in the 2 coordinates into their respective spots. So if I choose A and C here, I'm going to choose the top one, C, as coordinate 2, and I'm going to plug it in. So if you see, I now change the D to the length of segment AC because it's the actual length I'm trying to find. I said x2 up here is 2 minus x1 down here 2. So that's what I put in the parentheses here, 2 minus 2. Then y2 is 7 and y1 is 3. So I plug in 7 minus 3. And now that everything's plugged in, I first do the subtraction inside the parentheses first. Because there is no negative sign to worry about, 2 minus 2 becomes 0, so it just becomes 0 squared there. Same thing with 7 minus 3, it now becomes 4 squared. And now what I have to do is do 0 squared, 0, plus 4 squared, 16, and simplify. So I have AC equals the square root of 16. This one I should know off the top of my head, 4. So I get AC to equal 4. Now I'm going to do the same thing for lengths of line segments AB and lengths of line segments CB. However, I'm not going to show as much work with these two, but I will be plugging them into this distance formula. So when I plug it into the distance formula myself, I get that the length of segment AB is also 4, and the length of segment BC to be 4 times the square root of 2, or the square root of 32. Now what I notice is that this length here and this length here is congruent. So if I was going to classify it by its side lengths, I'd have to classify it as isosceles, not equilateral because the last side isn't there. So, isosceles. Now the next part, it says determine if it's a right triangle. If I had to take a wild guess, I'd have to say it was this angle here. Okay, I don't know if that's a right angle or not yet. So what I'm going to have to do is I'm going to have to use the slope formula. So I'm going to erase all my work for the distance formula and write the slope equation. Because if I don't use the slope equation, I can't tell for sure if they're perpendicular. However, if I know that the slopes are negative reciprocals, then I know that these lines are perpendicular. Again, if it's negative reciprocal slopes, then I know the lines are perpendicular. So if you remember, this is the slope equation. We just had it, so hopefully it's still fresh up there. Seeing that the two lines that I'm thinking are perpendicular is AC and AB, I'm only going to use those two slopes. If I get them to be perpendicular, great. If I don't, well then I know that I might have to try something else. So again here, what I'm going to have to do is choose one as the second point and one as the first point. C here is my second point, A is my first point, so let's plug in 7 minus 3 over 2 minus 2. So the slope of AC equals 7 minus 3 over 2 minus 2. That's what I get right there. And I label it slope of segment AB equals 7 minus 3 over 2 minus 2. Now I just simplify. I get the slope of line segment AC to be 4 over 0. What type of slope is that? If you said 0, if you said undefined, good. Remember, you cannot stand on a beach ball, but you can hold it over your head. We don't define this because you can't divide by 0. So, slope of AC is undefined. Now I'm going to do the same thing for AB. I'm going to plug into the slope formula. I'm not going to show my work again because my space is kind of limited. However, if I show my work real well, I should notice that my slope has a certain value. And that value is 0. So I have a slope that's 0, I have a slope that's undefined. It tells me they are perpendicular. However, it's not because they are negative reciprocals. In fact, they aren't. The reason I can tell they're perpendicular is because one's vertical, segment AC, and one's horizontal, segment AB. And I can tell that by their slopes. And vertical and perpendicular lines have to be perpendicular based on the theorem called slopes of perpendicular lines. So at this point, what I can now say is that this triangle is an isosceles right triangle. I box up my answer. Of course, I would have kept all my work and done. There we go. I've done number 1. And if I did this right, this should now pop up. Isosceles right triangle. And I realized that for the next one, I've already given away the answer. It's a scalene triangle. So if I would do this all over again, I wouldn't actually have to graph this except for the part that says graph it. And that is a part that we should be able to do quite well at this point. So instead what I'm going to do is I'm going to find the distance between all 3 points, or all 3 sets of points, and I'm also going to find the slopes of each of them and show you whether it's scalene or right. So if I look at the 3 slopes that I got when I calculated them, the first one I got -1/3, second one I got 3/2, and the last one I got -4. None of them are flip, so none of these can be perpendicular. And if they're not perpendicular, it can't be a right angle. Therefore, for number 2, it's a scalene triangle. I did all that without graphing it at all. You actually wouldn't need to graph it to be able to determine if it's a right triangle and determine if it's isosceles or not. If you're given coordinates like this, I think that's pretty amazing. Pretty awesome too. If you graphed it, it's pretty clear. It's a little bit questionable if it's a right angle, however it is not. Alright, concept 2. It's a pretty basic one. It's something about the sum of the interior angles of a triangle. And there's a theorem for us. It's the first one in section 4, called the triangle sum theorem. The sum of the measure of the interior angles of a triangle is 180 degrees. First things that we need to know is what is an interior angle of a triangle, and it's pretty kind of right there. It's the angles on the inside. So if I look at this triangle here, it's this angle formed right here. It's also, for instance, angle A here, or an angle B here, or angle C. These would all be examples of interior angles. And the sum means the result of adding. So if I would add up every angle of a triangle, it always has to be 180 degrees. Doesn't matter if it's acute, right, obtuse, equal angular, they're all 180 degrees. And that's what the triangle theorem says. If I would add all 3 together, 180 degrees. So let's try and apply this. So for instance, find the measures of the interior angles of the given triangles. Go ahead, try it. What you will see is that for all of these, we will add them up to be 180. So for instance, the number 1, what I will be doing is I'm going to say 55 degrees plus 90 degrees plus measure of angle C equals 180 degrees. That's for number 1. Now that I have it set up, solve for measure of angle C. So for measure of angle C, I get 35 degrees. Measure of angle A was given to me as 55 degrees. And measure of angle B was also given to me as 90 degrees. Now that I have all 3 of them, there I go. Number 1 is done. It asked me to find the measures of the interior angles of the given triangles, so I'm going to assume that they want me to list all 3, even the ones that were given to me. For number 2, when I do this problem, I won't just be finding x. However, I will set it up as if I am. So I add all 3 of them together, set them equal to 180. Now I combine all like terms on the left side. And it just so happens that 3x plus x plus 2x equals 6x, and negative 10 plus 10 equals 0. So on the left side, I get 6x. On the right side, I get 180. Divide both sides by 6, and I get x to be 30. With x being 30, I'm not done. Remember, it asked me for the measure of the interior angles. So, alright, I got x equals 30, but that's not what I'm looking for. I have to plug them back in. So, measure of angle D is 3 times 30, because it's 3 times x. Measure of angle D equals 90 degrees. Do the same things for angle E and angle F, now that we know what x is. Take a few seconds to do so. If you did it correctly, you should have got the measure of angle E to be 70 degrees and the measure of angle F to be 20 degrees. Again, if I do 90 plus 70 plus 20, I do get 180.